We've all been there. You ask an AI a question, and it gives you an answer that sounds brilliant, incredibly confident, and completely wrong. This happens because standard AI models have a built-in memory problem. Everything they know comes from a fixed snapshot of the world taken during their training. They don't know what happened this morning, and they certainly haven't seen your private files. Asking a standard AI a question is like forcing it to take a closed-book test, relying entirely on old memories. When its memory fails, it starts to panic, guessing and stitching together convincing fictions, what experts call a hallucination. If you're looking for factual, real-world answers, relying on an AI's internal memory alone is a major risk. But what if we changed the rules of the test? What if we gave the AI a way to stop guessing and start reading? This is the idea behind RAG, or Retrieval Augmented Generation. It's the technological equivalent of an open book exam. Instead of asking the AI to remember the answer, we look up the exact correct information from a source you trust. We grab those notes, hand them to the AI, and ask it to answer using only the context we just provided. This shifts the AI's entire job. It moves away from risky memorization and toward highly accurate reading comprehension. To make this work, we have to prepare the reading materials. You can't just hand an AI a 500-page manual all at once. It's simply too much information to process at a single glance. So we take your documents, like PDFs or company wikis, and we slice them into smaller, bite-sized pieces. Think of it like taking a giant, heavy textbook and turning it into a manageable stack of flashcards. By breaking the data down this way, we ensure the AI only receives the most relevant information later on, rather than being overwhelmed by noise it doesn't need. But if you have thousands of these flashcards, how do you find the exact right one the moment a user asks a question? To solve this, the system converts text meaning into numerical coordinates on a digital map. This groups similar ideas automatically, like a grocery store putting all fruits in one aisle. You don't need to know where every apple is to start looking. These numerical coordinates are stored in a specialized digital filing cabinet that is built to search through these meaning maps at lightning speed. By turning human language into these coordinates, the computer can instantly navigate millions of ideas and pinpoint the one that matches your needs. When you type a question, the system does the exact same thing to your words. It finds their specific coordinate on that map. Then it looks for informational flashcards mathematically closest to your question. This matches meaning, not just words. A question about a refund pulls a note about a return policy, because the system knows those concepts are neighbors on the map. This means you don't have to use the perfect jargon to get an answer. The system understands what you're looking for and grabs the right context every time. In the final stage, those perfectly matched notes are stapled to your original question and handed to the AI. Now the AI has everything it needs. It reads the notes and crafts a grounded, accurate answer, and it can show you exactly where it found that information by citing its sources. This keeps your private data secure, allows for real-time updates without retraining the model, and is much faster than trying to teach the AI everything from scratch. Because the AI is reading from the page rather than relying on its memory, it stays on track. This dramatically reduces the chances of the AI inventing a false answer. This system provides the reliable, factual memory required for the next generation of AI assistants, the kind that can actually be trusted to perform tasks and make decisions based on real-world data. Reliability comes down to one golden rule: retrieve the factual notes first, then let the AI reason using only what is on the page.